Alright, this begins our second part of looking at location tolerances today. And let's see, get my technology running here. In this portion of the chapter, of the topic, we're looking at multiple features and composite features as well, the way we position those. So a lot of times, a lot of parts have more than just one hole, and those holes need to be grouped. And so the examples that we have in the book are like, generic kind of parts, so that we can focus on the dimensioning process and actually how it functions. Then your print reading, gets into real applications. There's some of that in your prints. So there's a couple of ways we locate multiple features. We use the rectangular coordinate dimensioning system, like so, when the holes are arranged in a rectangular fashion. This happens to be kind of square. Then there are situations where we have polar coordinate needed, like this flange or cap or whatever it might be, hub. And we have two basic specifications required for polar, which would be the diameter that the holes are located on, or shapes are located on, features, and then their spacing, whatever it might be. The single composite pattern, which is the simplest application for this, takes the series of holes, applies basic dimensions, so we have a framework established from our datums, in this case B and C. Then interpreting it, the meaning of it is these dimensions would be perfect, and attached to the center of where these dimensions 15 and 20 cross is a diameter tolerance zone that's basically cylindrical, and in this case it's 5/100ths of a millimeter at MMC, because we got that circle M thing going on, and then it's allowed to increase as it departs from MMC and goes all the way up to 0.85. So it's a huge location tolerance. So the center of the hole of the pattern, that is, can actually locate all the way over. Okay, all the holes are checked together in a pattern. Okay, so these holes, by virtue of how these might be drilled, manufactured, they're probably going to end up in a pattern that is similar. But if you think about it, the center of this hole that's black right here, it could end up all the way over here. So that means the whole center would be right here, and so it would be, the edge of the hole could be all the way over here. Still be a good part. So it must be a very tiny, a pretty small shaft that would fit down in there, and still locate. So kind of exaggeration, I guess, is what I'm pointing out to you. The way they're doing their examples, they're exaggerating quite a bit so that you can see the difference, because in reality this would probably be a whole lot tighter, and the pattern as far as MMC, we might be controlling the size quite a bit. Instead of a plus or minus 0.4, it might be 0.04. Okay, so we have a smaller range to locate in. Now, locating features with separate requirements, there's really no example. I didn't look up one, but there's not one really. Basically, when we want to treat the patterns separately, okay, so when features in one pattern are different in size or have different location requirements, then we have to put underneath the frame SEP space REQT. So the only one they have is just this one here, where we have 14 this way. See, it's a circular part, so it's not using polar, it's using rectangular, and you'll see that a lot. And so these holes are located 12 basic off the center. Then these large holes are 17 off center, and then these are right on the center, and then these two holes are located at 14. So we've got, you know, 3 different basic measurements controlling where the holes are located. The pattern frame, if you will, is located. So to be sure that no one considers them all together, since there are different measurements, we put the SEP REQT underneath the frame. Then we can specify positional tolerance individually, and we use this when we have multiple datum references. We place a note next to the datum feature symbols and the related feature control frame to identify how many datum features and position tolerance specifications to consider individually. So we just put 2x individually, and there's really not a graphic for that. Okay, so basically just be aware of it. If you see it on a print, it's when we have multiple datum reference frames. Composite positional tolerancing, now that's on page 249. So let's see if I have a graphic for that. Okay, so basically here's the drawing. We have a pattern, okay, that's listed first. It's a composite positional tolerancing, and then a feature relating. Okay, so use one positional geometric characteristic symbol in one double height feature control frame. So that's this. Then we specify a pattern locating control in the upper part, and then specify feature relating control in the lower. So this upper part is controlling the pattern, how the pattern itself, which is basically dictated by this measurement and these specifications. So 20, 35, and then 18. You can see it's related to A, B, and C. The pattern is 18, and then to C, 20 and 35. Then the feature relating is actually the hole itself. So the pattern, you know, fairly large, 0.6 of a millimeter, 6/100ths of a millimeter, 6/10ths of a millimeter, and then 15/100ths of a millimeter for the feature. So when we put that all together and try to map it out, you can see what happens up here. The actual pattern, you can see they must always be 35 millimeters apart. Okay, but it's not controlled, does not have to be perpendicular, okay, to the part, as long as the centers are 35 millimeters. All right, so your shaded part right here is your feature. Okay, so at MMC it's 0.15. Then your